Hi, everyone. I'm Nate Miller, co-founder and VP of Data Science here at Unearth. On behalf of the entire Unearth team, welcome to today's Fireside Chat. This is part of an ongoing series of virtual events we're hosting to dive deep into the issues that matter in utilities, tech, and society. Today, we welcome Danielle Merfeld, an accomplished woman in the utilities and built world. Danielle is a Chief Executive Technology Officer of GE Renewable Energy, reporting to the CEO. In this role, she leads technical efforts to develop differentiated projects and services across the broadest renewable energy portfolio in the industry, including offshore wind, onshore wind, grid solutions, solar, batteries, and hydro. She also champions sustainability efforts across the business, leading a team focused on achieving carbon neutrality, and leads the GE Renewable Energy Edison Engineering Program. Additionally, Danielle serves as co-leader of the GE Women's Network, a global organization focused on recruiting, retention, development, and promotion of talented women across GE. She was elected to the National Academy of Engineering in 2021. Danielle was recognized by the New York Capital Region Chamber of Commerce with the Women of Excellence Award in 2016, was named Woman of the Year by the Cleany Awards in 2018, and recognized in the top 5 of 2020 North American Power List. Danielle received her BS degree in electrical engineering from the University of Notre Dame, a PhD in electrical engineering from Northwestern University. She has authored or co-authored over 70 papers in refereed technical journals and has given presentations at conferences and symposiums around the world. Danielle is also on the board of Advanced Energy Economy Organization. Most notably, this past Friday, Danielle addressed world leaders at the State Department's Leaders Summit on Climate, sharing her insights on how we together can unleash climate innovation. Danielle, welcome. It's truly an honor to have you join us today. I believe it's clear to everyone who's with us that these accomplishments didn't happen overnight. Would you mind telling us a little bit about your journey and how you found the energy sector?
Sure, Nate, and thanks for having me on. I've been with GE for 21 years now, and I would say I joined GE because they were doing a lot of cool stuff. I mean, that was really as simple as it was. I wasn't really engaged in the energy sector. I was just an engineer looking to work on interesting, tough problems that made a difference in the world. My first projects were in helping transition from conventional, luminescent lighting, like incandescent lighting, to LED lighting. So that was my first taste of energy efficiency. And through that and other technical arena, just growing my career, everything started to lead to energy. First solar, and then wind, and now the whole portfolio of renewable energy and grid, which is just so exciting. So I think once you find something that's exciting and has growth, and if it's a passion, you just kind of gravitate to it, and then that becomes what you do.
Nice. What were some of the early signs that this was a passion of yours? Because I hear a lot of passion coming through. When did you first get that inkling?
Well, it didn't start with energy. My first inkling was just generally technology. And I would say lasers were really cool. I got a chance to do a summer internship at a laser lab at a Air Force base when I was in high school. And I thought, well, if I have to have a job, I want to get paid well, and I want to do something I really like. And somebody said engineering will do that. And so I thought, well, how do I play with lasers as an engineer? And so that was the first step. Then solar was cool because working in LEDs, you could make light. It wasn't a laser, but it still was something I could see. It wasn't just, in a computer or in a book somewhere. And then moving to solar was just an LED run backwards. I mean, literally, it was just step by step. So all those pieces, every step, there was some like spark that made me fall in love again with what I was doing and take the next step into the next thing. So maybe it's hard to say there was any one thing, but early on, I think it was just excitement for learning something new.
Very cool. So it's been said that the essence of strategy is choosing what not to do. Along your journey, what have been some of the toughest things that you've had to say no to?
That's a great question. One of the first times I said no to something was when I was just a new undergraduate. I had just taken a job before I decided to go get my PhD down in Texas, and I was excited to do the work, and I went to show up, and I realized maybe it wasn't going to be everything that panned out because I was just going to have to follow other people's instructions. But I really wanted to work because I really was sick of being a broke student. And the first time I really had to say no to something I wanted which was also, we say no a lot, but saying no to something you really want is it's the thing you remember, and it's the hard thing to do. And I said no to a secure paycheck. And I said, okay, well, if I'm going to be doing this the rest of my life, because when you're 20 years old, everything is forever. When you make these decisions, I thought, well, at least I want to tell myself what to do. I don't want to be told by someone else's interests what I should be working on. So I just decided to forego what would have been a very comfortable start to my adulthood, and I just stayed poor for another 6 years and went and got my PhD. And then, of course, it's a much better life, a bigger paycheck at the end of that. But I think that suppressing that instinct to take care of myself and to put myself into a comfortable position was maybe the first time I said no. And then after that, career decisions to say no to projects or opportunity, I don't really think any of them were that notable, probably because I didn't want them as much as I wanted that first paycheck.
For folks that might be on the fence about taking advanced degrees, a PhD in science, how has that impacted your career and allowed you to do the things that you want to do?
Oh, so I did it initially because I thought I would be in control more. I'd be in charge. I'd get to decide what I worked on, because my fear was working on something that was not exciting to me. There's a lot of fun technology work out there. I didn't want to get stuck on something that just wasn't my thing. But in reality, what I found was it gives you a depth of capability to bring to your problems, even if it's a different field entirely. You kind of have an appreciation for how hard it is to know something deeply, and you recognize it in other people a little bit easier. So that's been probably one of the best things I've used for my PhD, not the actual technology work that I did, but the ability to recognize expertise in other people, to appreciate how hard challenges can be and how long things take to get right, and how important they are to get right, because the easy answer might not be the right answer. So I think it's the philosophy that it gave me was probably the biggest value. Now, I don't recommend that everybody go get a PhD, because not every job or philosophy requires that. So it's really just about, is it something that's going to make you better at what you love doing? And in my case, I thought it would, and it did, but for a different reason. And I think everybody's kind of got their own path to find.
Oh, that's a great answer. Thank you so much for that. It's always fun to hear how people come to those answers. And speaking of expertise in general, and the people that have helped you along the way, tell us about a mentor or teacher who has been critical to your success.
Yeah, well, I think one thing in anyone's career is you have to find who is your coach, who's your mentor, and who's your sponsor. And so I'll give you an example of a mentor / sponsor for me, because my early career I was very early moving into a leadership role before I felt ready, before I was sort of accomplished enough to believe that that everyone around me would agree that I was worth that role, right? So some of my earliest mentors were just the ones who inspired confidence in me that I could do it, or that nobody really knows that, or hey, you can learn, you'll get there. So there were some really great, more senior initial leaders. In my first role, I was running a lab, so other lab managers who had been doing it for a long time. And they just sort of said, trust the process. If you don't know what you're doing, follow a process. If you want to change the process, talk to people, because you might have a better idea. Just trust your instincts, but keep people engaged. So I think just basic leadership, but the best things that I look back on were where a mentor turned into a sponsor. And the difference between the two, mentors will sort of share their experience with you so that you can not make the same mistakes, or that you can learn from their guidance. A sponsor will actually give you opportunity, will pick you for a role, will highlight you for a promotion. And now it's a two-way street. If you're going to get promoted to do something, you're going to have to deliver on that. You're going to, whatever spark that leader saw in you, you deliver on it through great execution or through innovation or creativity. It's not a gift. It's a contract of relationship for how work gets done. So I think that was something that I didn't understand at first. And then when I got these opportunities and I realized that I'm helping them and they're helping me, then I realized, wait a sec, I could be doing that for people behind me, helping the whole flow of people that I thought would be great at this work. So I think some of those early role models in sponsorship helped me become a better sponsor too.
Oh, that's fantastic. It's clear that you have a lot of experience being a sponsor within GE and helping raise women and other folks to the front. How do we get more women, diverse candidates, and other high talent individuals interested in STEM, science, technology, engineering, and math?
Yeah, I don't know that it's as much of a problem of getting them interested. It's more about keeping them interested when maybe the world around them is telling them they shouldn't be, or not being very a good host for that interest. And then, especially if they're already in a career position, creating the culture for them to succeed. And a lot of this has to do with, our society. So that's slow to change, and it's maybe just every little by little you want to encourage, say, young girls to try things that maybe aren't in the girl toy aisle when they were growing up. So that's one thing we all can do. And I think society, at least in the US, there's starting to be big change in that, in the generation of parents and how they're raising their kids, boys and girls, to be a little bit less um, severe about what the constraints are around their gender and what that means they're allowed to do or wear or like or dislike. But I think within a company, it's not as much about getting women interested or keeping women interested, or any people who aren't the typical, in my world, engineer. It's about just removing bias. And the bias isn't, there's certainly bias in all of us, but we build bias into our processes too, our hiring process, our recruiting processes, what schools we go to, what things we look for, even what questions we ask people when we're interviewing them. So it takes a long time to engineer bias out of your brain, and you can do a lot through training and awareness, and everybody should do that for sure. But it's not that costly or hard, or doesn't take that long to engineer it out of your processes. You just have to be very thoughtful and explicit about what that process is supposed to do, and how to make it more fair and balanced, and how to take as much human bias out of it. And you can actually get results pretty fast. And there's been great examples across the corporate world where people have done that kind of thing.
Oh, that's great. No, thank you for that. Speaking just about the growth of STEM, and perhaps to speaking to the nature that we don't need to get people as interested in it. Perhaps there's more other systemic challenges that are involved. I wanted to share an interesting statistic. So the Bureau of Labor Statistics is forecasting that STEM jobs are expected to grow double the rate of all non-STEM jobs throughout the decade. With so many incredible opportunities available to these candidates that are coming out of school, why should they consider a career in the energy sector?
Oh, well, I would say the best part about, so STEM is great. All of the technologies lead to great things for for humanity. I guess I'll start at the very big level. Very few of them rise to the level of energy in terms of impact on society, touching every part of our world, from education and training, and how do people get the ability to learn and to do things just because of the nature of how learning is delivered, all the way to, of course, the climate and the energy sector is responsible for about 78% of our global greenhouse emissions. So, I mean, if you just want to say the biggest threat to humanity is climate change and our inability to stop adding carbon to the atmosphere, or even managing the carbon that's there now, and you want to do something about it, 78% of the problem is the energy sector. So that means there's a huge opportunity for change. And I think any person in STEM, any person in any role really, wants to make a difference, wants to have an impact and feel like they are doing something that matters. And I know, growing up, my father was in the military, my mom did a lot of teaching. They did it because it mattered to them, and they were good at it, and it felt good. I think it's pretty easy in STEM to find things like that. Very difficult to find something like that at this level. And the energy sector gives you all of those high notes about, your very local environment. You can see a change, but you can also see this change at the macro kind of global scale. And it's cool.
Right? I mean,
Yeah.
how cool is it to be able to work on problems that literally change the world around us? And, segueing into that, I'd love to talk a little bit just about innovation, and specifically market-led innovation, and the role that you played in that in your career. Thomas Edison once remarked, "I find out what the world needs, then I proceed to invent it." In the renewable energy sector, what does the world need right now?
It needs even cheaper renewable energy, but it also needs to have that renewable energy be allowed to go onto a grid, our electric grid, and not destabilize the grid. Like, one thing that, just a quick little sidebar, because it's just a cool fun fact. The grid was designed by a lot of GE engineers back about 120 years ago, in a very elegant way. It actually takes advantage of this the rotating inertia of these big turbines. They were steam turbines, now they're more increasingly gas turbines or even hydro turbines, but you've got this big metal spinning part that's turning a generator that creates AC power that goes onto the grid. That speed of turning, which you can regulate by the water flow or the fuel flow, it defines the frequency of your electricity, 60 hertz in the US. So there's a lot of inertia. If some hiccup happens, it doesn't stop. If the fuel has a bubble or something, it doesn't stop spinning. Their inertia keeps it spinning. So the system, the whole AC grid, has this really nice cushion. It's like a shock absorber almost, because all these synchronous generators is what they're called. They are synchronous with this frequency of the grid. When you have a wind farm or a solar farm or batteries, they don't have some, I mean, in some cases they might have something spinning, but they generate electricity and put it on the grid in a very different way. It goes through power electronics. So think ones and zeros instead of sine waves. And it can create a waveform that goes onto the grid, but it's not, there's no inertia. So now the grid is getting a very different kind of signal. And when you put more renewable energy on the grid, it could disrupt the grid. It could actually create a problem. Or you could turn it around and say, oh, but these are like imminently programmable and they're fast and you can do any waveform, any shape, you could manage any fault. If you think about it differently and not like, how do I make these new features fit the old model, but how do I redesign the grid? Could that grid be like completely decentralized and resilient and, all these impacts of weather and cyber and all those things are much easier to manage now, but you got to rethink the whole thing. And I think I don't know how I even got on this tangent, but the idea of energy being something like, what do you need for it? Yes, you need renewable energy, but it's more than that. Like this layers of challenge that you get into that I think are highly inspiring and exciting, because it's not just solving the problem, it's taking the problem and turning it around and making it a whole new step forward for the whole institution.
Got it. Well, let's take this segue even further, and let's imagine that next year GE creates the world's first time machine, and you can travel back to 1882, the birth of the modern electric grid in Lower Manhattan. What advice would you give for the architects that created the U.S. power grid?
Oh, that's a great. Well, so one of the big decisions that had to be made early on was whether or not that grid would be based on AC or DC power. And it's probably, many of your listeners would already be familiar with this. Thomas Edison said DC power is better, and Tesla and Westinghouse famously said, no, AC power is better. And at the time, AC is the right answer because it's generally safer. The waveform passes through zero, you can control it, but even more important, the voltage can be moved, right? Because that waveform is the way it is, you can use a transformer, is what it's called, to make the voltage go very high. Then you can send it across a long distance and then bring it back down. If you're sending lower voltage across a long distance, it dissipates too quickly. So there was a good reason why we chose AC back then, but I would, there are some reasons why transformers didn't do this for DC, but now we have technology that can do that for DC. It's still not fundamentally going to change the grid in the short term, but now you can think, well, wait a second. Now most of our loads are DC, computers, big server farms, even our appliances in our house use power electronics. They need a DC source. So, the brick that you plug into the wall that goes to your computer, that's a transformer. It's taking the AC off the electrical line and making it DC for your electronics. So I think there's now to a point where maybe the DC grid or some portions of the grid, or even just your home is DC, that might have been something as a hybrid model we would have gotten to much more efficient earlier. I still don't think it would be the right answer for the late 1800s, but it would have been nice to inject some sense, because Thomas Edison, in his desire to tell the world why DC was better, tried to show how unsafe AC was by staging these elaborate death traps of AC power, which is much more dangerous than DC power. In reality, at one point, he designed what became the electric chair and showed how it could kill someone, and I called it the Westinghouse chair. He even, I think, had an elephant executed in a town square just to show how dangerous. It was awful, horrible part of the history of the current wars is what they call it. But, people back then, I think, just wanted to make their point. I'm glad we don't do that these days.
That's true. You know, we're hitting on an interesting subject here, which is that we're not in 1882 anymore, and a lot of the world is developing at different paces. The University of Oxford, for instance, in Nature earlier this year, predicted that energy demand in the continent of Africa is expected to double its current amount by 2030. How will Africa's growth influence the solutions that are deployed in the region?
Well, if you think about what exactly happened in Africa with telephones, right? So I would say 20 years ago, you might look at Africa and say it's going to be impossible for people in these remote villages to have any kind of access to transmission of information through a telephone, because it just takes so much time and energy and resources to build the infrastructure of all the telephone wires, right? Well, you know what happened in Africa. They did a leapfrog event over with that, and within most of the countries in that continent, where they didn't ever build out infrastructure for telephone lines. They went right to cellular. And now there's more people that have cell phones in Africa than had cell phones in the US 10 years ago. And it's much more a part of their daily life, their banking. It's enabled a whole different quality of life for many people in remote villages that don't even have power. I mean, they've got community solar just to charge their cell phones. And that's obviously an extreme example. There's plenty of parts of Africa that not only have cell phones and power, they also have landlines, so it's not universal. But if you think about that as your example, what about power is, we always think about it as very centralized. There's big power plants, and then there's long transmission lines, and they go to people's homes, and you have a line going all the way to your home. There will likely be a leapfrog event very similar to the cell phone leapfrog, where you're going to have power created where you need it. You're going to have cell phones on roofs. You're going to have a local microgrid maybe, so that there's more stability and people can share some of that stored power. You'll have either batteries or hydro or mechanical forms of energy storage. There's just so much variability and just awesomeness in the diversity of energy resources that there's no one size fits all. So every region has its own solutions. Kenya is has the largest amount of geothermal in the world per capita. The US has the largest amount, but who would have thought? And it's because they have a very specific resource that they're taking advantage of. And I think that's the answer for the future. Big countries, little countries, developed and undeveloped, all have a special niche where they get the best answer for them in a new way.
You know, it really seems to me like one of GE's real strengths in the market is determining kind of the matrix of the different local economic structures, the market structures that are going on, and then finding the right energy solutions there. I was curious, would you be able to share some other examples around the world of how these different market structures lead to different energy solutions, right? I just find this fascinating.
Yeah, well, I think it's not so much just the market structures, it's also the resources. So I think it's a combination of market and resources. And I'll say, let's just take the resources out of it, because there's a really good example where the resources actually play in the opposite direction. Germany, 8 years ago, probably had some of the highest installed rates for solar, especially in people's homes. And that's because they were incentivizing solar. They had the feed-in tariff. So if you were making solar on your roof, and you weren't using it all in your home, you could feed it back into the electrical system and they would pay you a certain amount. And it was predetermined for 10 years. So people could do the math, figure out how much solar they could put on their roof. And effectively, they created this endowment of investment. They knew the payback. They could borrow money from a bank that they wouldn't be able to afford on their own, but they had an income that they could point to pay back that loan. So all the people I know in Germany that had their own roofs put solar on the roof, and sometimes even used batteries to sell the power at other times of day when the feed-in tariff became geared towards different value at different times of day. Germany has about the same amount of sunlight as Alaska. So this is not because solar was a really great resource there, but they engineered their market to drive solar adoption because it was part of their mission. We've seen that happen all over the world. The design of the market engineers the solution. And right now the US market is designed around energy. So if you're making electrons and they go on the grid, you get paid for them. And we have some feed-in tariff places, but generally this is how utilities work. The problem with that is when you're making a lot of energy when people don't always need it, is it really worth the same as when you're making energy and a lot of people need energy at that time? Like when the ACs are cranked up all the way versus in the middle of the night when no one's awake and the factories are all shut down. So the US is starting to think about, okay, renewable energy means that fuel is free. So nobody's going to turn down, you would just turn down a gas plant and not run it as much if you didn't need it as much. And it's really good economic balance. If the wind is blowing, your turbines are going to be making electricity. What if they're making more electricity than people need? That turns the market upside down, and now they have to pay to put, it becomes a negative pricing. It's just strange market dynamics. So the new view in the US is thinking about, what about paying for flexibility or paying for capacity? Those are not part of our market structures generally yet. So the markets matter a lot.
Yeah, I find this interesting because so much of talk about the smart grid and the things that I've read is about figuring out how to store and then sell this energy on the market at the right times. I'm curious, from your perspective, how is IoT, artificial intelligence, powering the transformation of our electrical grid right now?
There's so much potential. I would say it's still at the very first chapter of that story, lots of potential. And the technology is one piece. So how do you store it? How do you deliver it and absorb it? But even more important, I think we're at the stage now where it's, how do you see it? How does a utility operator have visibility to that distribution level? How do they know what's happening in your home and how much you might have stored in your car battery that you might plug in later or you might not? It's one thing to incentivize it through market structures, but if they're going to balance the grid, and maybe I should be very clear, there's no storage in the grid. When there is electricity put on the grid, at the same exact minute, it has to be taken off. It's balanced. That's what they call a balanced grid. So the load has to be balanced to the generation at all times. If the load goes up, the generation has to go up. If the load goes down, the generation has to go down, which means you might be, like, we call it spilling. You might just be curtailing or spilling over some of that excess electricity in resistor banks because you just can't use it. You don't want that. That's inefficient. But that balance is really important. So ultimately, the piece that's missing right now isn't the how do you store it, but how do you see it and how do you control it? And I would say there's a lot of innovation happening at the distribution level to give small companies and municipalities, but also homeowners and car owners, the ability to participate in these markets that didn't exist a few years ago.
Yeah,
and maybe still don't exist in some places.
Yeah, no, this is a really interesting topic, right? Let's talk about the distribution a little bit more. So the US power grid is changing from a heavily centralized model to one of a more distributed. And utilities in rural communities have historically favored larger, less expensive generation assets. I'd be curious to hear from you. How has this changed since you started your job at G&E in the last 20 years? What have you seen happen?
Yeah, well, I say the large rural preference that you state is probably most notable in the Midwest. And the biggest change just in the last 10 years is the shift to wind. They're still big compared to, you look at a wind turbine, you're like, wow, that's big. But putting 1 or 2 wind turbines on your land is nothing compared to a big coal plant down the road. So you'd need dozens or hundreds of those even to compare to what would have been a big centralized system. So we're already seeing this huge decentralization of power. Now it all goes onto the transmission grid. It's used in the state, but then it's also sent to the neighboring states that might need excess power. But it's giving farmers who own land a whole new resource and a whole new income, because they're not just farming their land, they're farming the wind that's blowing across their land, and they're able to make money off that and put it into the electrical grid.
Thank you. No, that's fascinating. And I know this next question we could probably spend an hour talking about. And I know that you got off the phone with the White House just before this call to talk about it. I'd just be curious, from your perspective, what kind of changes are needed to incentivize energy markets to choose these types of sustainable energy sources?
Well, one of the things that this administration is considering right now is a clean electricity standard. And that's a policy mechanism. It's not, this is something that would be really guidance, right? Sometimes you don't always know what the best solutions are. In fact, you might even choose a couple different solutions in different places. And if they interact in a negative way, the answer is not good. So in some cases, and this is probably the example that the administration will give as they're selling this idea, it makes sense to just create the rules at the top and then let the markets figure it out, or let technology figure it out. So one rule that they're proposing is saying we have to have a standard where if you're going to put new electricity onto the grid, new generation of electricity onto the grid, a certain percent of it has to be zero carbon. So you can do whatever you want, you can put as much or as little on, but you have to guarantee that some percent, and in this case it would be an 80%, for example, of your new electricity. Like if you're a big utility, you can put all these different things on the grid, but they have to add up to so much is carbon free. And when you do that top line policy, you're doing enough shaping of what you want the answer to be, but you're letting people figure out how to get there. You know, as long as they're not picking winners or losers or technology that does or doesn't work, the markets can sort of sort the rest out. And there's other ways to do it through tax policy. I mean, there's 1,000 different policy mechanisms to encourage people to do something that isn't always the cheapest. Coal was the cheapest form of energy for a long time. Lucky for us, it's now wind and solar. It is literally with no subsidies, wind and solar is the cheapest. But you still need things like coal or gas or nuclear because you have to balance when wind and solar are available because they're variable. So how do you incentivize other things? Because really you can't afford all that carbon, but who's paying for the carbon? It's in our health, it's in our welfare, it's in, you know, life, it's in our life expectancies. That's a really hard thing to measure and have somebody pay for. So those top line policies are one way of trying to create market mechanisms for things that you don't pay for or get paid for, like health and human well-being and happiness or community growth.
That's a really great response. Thank you for that. And I think this really tees up well a topic of hybridization in the United States, of being able to combine these sustainable energy sources with traditional ones. What are some of the interesting things that you're seeing in the field of hybridization at GE right now that are getting you excited?
Yeah, so we have been combining energy storage. So because of the EV growth, prices of lithium-ion batteries have come way down, over 90% reduction in the last decade. So much, much cheaper than they were before, and which allows them to be used for a lot of other things besides just driving a car around or propelling a car. You can also use them to store electricity, and maybe in the heat of the day, you've got plenty of solar, but when you come home from work and there's this tail where the sun is setting, but people are cooking dinner and they're turning on their lights and factories still haven't completely shut off. That's this end of day bump where solar can't be there for you unless you hybridize your solar system or your grid with energy storage. And then you can sort of say, I'm going to capture these couple hours of solar, but I'm going to use them after the sun sets when I still need energy, but I don't have active solar. So that's one way to sort of combine technologies and create this hybrid solution, which I love the idea of hybrid, because not only are you sort of picking and choosing the best way to solve a problem, you're solving a hybrid problem. You're solving an economic, a societal and a technical problem all at once.
That's great. All right, thank you. We've talked a lot about market-led innovation and incentives, essentially what Edison remarked earlier in the quote I gave of identifying the need. What I'd love to talk about a little bit more is just the process of invention. How do you make things happen fast at GE?
Oh, that's a good question. The fastest things happen, I wouldn't say serendipity, but it's sort of being in the right place at the right time and being able to connect the dots. And I'll give you one example. So, and we find this a lot in GE because we work in very different fields. Like we have a healthcare business, we have an aviation business that makes jet engines, we have an energy business that makes all these renewable parts and components and systems. So in our healthcare business, there was an innovation almost 10 years ago that I remember from my time at the research center, where they developed a superconducting generator to help run MRI system, these rotating magnets that allow you to look inside the human body instead of doing, cutting people open and looking inside. And it was this really cool innovation that allowed you to make this superconductive magnet smaller, less helium, which is always a pain to refill and very costly. And it was really beautiful, and it allowed a lot of new MRI systems to go to much more remote places in the world that didn't have the same infrastructure that a big city would have. Well, fast forward 10 years and we're building these beautiful big offshore wind turbines. And the bigger the top of the turbine, the nacelle, where the generator is, essentially the motor run backwards, the bigger that is, the heavier it is. And the heavier and bigger anything is at the top of a couple 100-feet tower, the more expensive it is to build that tower. More structure, more steel, more concrete. So anytime you put like $1 of cost up in the top, you're adding like $1.50 of cost for the rest of the structure to hold it up that high. So if you're going to build, and we have right now a 14 megawatt wind turbine, the blades, each blade is longer than a football field plus the end zones, and you've got 3 of them, right, circling around this huge nacelle that's like a 3-story tall building on the top of this huge wind tower. And we have vessels that can bring these out and cranes that can lift it up, but everything's sort of just at the edge of what could be done. Like you get much bigger and this thing doesn't work anymore. This is a picture of the 6 megawatt version of it. So it's a little smaller, but these things are massive. Now, what we did was we said, oh, wait a second. One way to make that generator more efficient and go from like, 40% more power, but not any bigger of a generator would be to use this superconductive capability. And by the way, we already invented it over here for an MRI system, but it's much smaller in an MRI system than this big beast. So right now we're actually working with the Department of Energy to demonstrate scaling that up. And now we've got, and this is why I say it's quick, because we're taking something from one area and putting it in another. We don't have to reinvent. The really hard part was developing the supply chain and testing all the theories of how it would work. We have 10 years of MRIs working in the field now. We know what the breaking points are. We know how to build it. We know where to get the supplies from. We just have to make it a little bigger, well, a lot bigger, and make sure that still uses the same laws of physics, which it does. And so this is really just a great example of being able to innovate a next generation offshore wind turbine based on something that was completely in a different field. And the side benefit is by using the superconductive generator, we're moving away from permanent magnet generators, which use rare earth materials that are really hard to find and mostly come from China and are really bad for the environment because you just have to bring up so much material to sort these little bits out. So it's like, layers of goodness in this whole story.
That's absolutely fascinating, the way that healthcare can influence energy innovation. And it certainly sounds like there was a lot of work and a lot of consultation across the world that went into these products. And a big part of novel invention like this is it requires extensive experimentation, but also failure. How do you know when a promising project is no longer worth pursuing?
Well, the important thing is to set up a roadmap ahead of time. So before you even start the journey of trying things that will fail, and some things you want to try the things that could kill it, you want to try them first. If there's an experiment that you could do, if you can't pass this certain hurdle, you should stop. You do that one first, right? And the idea of setting up a whole program to develop something is picking the right things in the right order to try out and knowing what the signposts are along the way. Imagine you're like on a journey, you're Lewis and Clark, you're traveling across the US for the first time. You might know just from stories that there's a mountain west, but when you walk there, you might not realize, well, there's this huge valley with a cliff and a river, and you might not be able to just head west to get to that mountain. You might be able to see the mountain, but that's the destination, that's not the journey. So you need to figure out what your signposts are along the way. And when is it just a pivot? I'm gonna find a different route because there's this huge gulf between me and the other part of the path, or just a big wall that you cannot pass or isn't worth passing. And that's why setting it up ahead of time, knowing what you should be looking out for, stops the emotion from taking over when you're in the journey and you just want to jump across the gap because you want to get to the other side. And
yes. Working in innovation sectors, the failure is just part of it, and detaching that emotion and being able to turn it into something powerful is really great. So thank you for sharing that expertise from your side. Talking just a little bit about, going back to some of the Biden administration stuff and some of the warnings that we've heard from the Biden administration, and that its pursuit of decarbonization technology is that innovative technology is not going to be enough to achieve our net zero goal by 2050. And I know you've hit on this a little bit, but from your view, what else must change besides the technology for us to reach this net zero goal in 2050?
Well, I think technology is a big part of it, but it doesn't always position itself as technology is the goal. We're looking really to change how our systems operate and reward things that are good for us in a net effect, rather than just, how do companies make money? If they're making money, or if you're selling something that has a value, are you really looking at the big picture? So I would say the other pieces that aren't just technology are changing our economic view to what value is, what's worth something, and how do you measure that worth, and how do you compensate people for that worth? What's it worth to burn more carbon? We're going to do it. Is it worth something? What is it worth to have kids who can be educated, or have a whole workforce be educated to a certain level? That's worth something to a community. It's worth something to have supply chain in the country, so you don't have to bring it from another country that you might not have access to if the Suez Canal gets blocked, or if somebody goes to war, or if there's a earthquake. So I think there's just these very interesting dynamics about value that we've got to get used to, and we've got to start creating frameworks for how to do economics that aren't just about product value and service value. We do those really well today, but there's more than just those.
Right. Right. It seems like a lot of this, like one of the central themes of our talk is convergence, right? Like bringing different things together, different people, different technologies, different strengths. And this is one of GE's biggest strengths. 68% of the employees of GE are based outside of the United States. How does this diversity fuel GE's ability to innovate?
I think everybody probably has heard the factoids about diversity, so I won't repeat them all, but I think one thing that's really true that I see in GE all the time is different life experiences, different perspectives and approaches give you kind of a better answer. If you're like, when I think about it as addressing a challenge, they also give you a better risk profile. You have a different way to see like outcomes for customers. You have more empathy when you can put yourself in somebody's shoes, or somebody on your team can put themselves in the shoes of a customer or a partner, or even a peer, in the company. So just having a lot of different perspectives that are all welcome and have a role to play gives you, I think, a cushion of error. You can be wrong a little more because you're more right when you are right. And seeing around corners helps when you've got people who have already been there, or who understand that challenge in a different way than the rest of the people on the team. So we've had a pretty diverse company. It's been a global institution for quite a while, but part of the reason why we have over 68% of our employees outside the US is we have over 68% of our customers outside the US. So we are where our customers are. We are living and working in the fields where we're operating. And that's the piece that's the great one. We're not sending people from one country to go be the leaders in all the other countries. We're building that across our community of GE leaders.
That's great. I want to talk a little bit more about the project that we mentioned a little bit earlier, and taking place in the Netherlands and also Denmark. I've been so excited to learn from you just a little bit more about these offshore wind farms. Specifically, the question I have for you is, how do you design a wind farm? How do you even get started across that process?
Well, so I think it starts with the turbine itself. So our offshore wind turbines are based on a lot of knowledge from our onshore wind turbines. We've been in the onshore wind game for a long time. We're the largest manufacturer and supplier for the US. So this is something that's in our blood. We've got a lot of technology capability here. Moving to offshore, it gets harder and easier in different ways, right? There's a lot more value to being bigger. So now we've got to develop models and understanding about how does this scale, and how does it scale in a way that's still really high quality, because we never want to visit these things. I mean, we will have to at some point, but as infrequently as possible, because you have to get on a boat and drive a few hours, and you have to have a special vessel that can dock at one of these wind farm or wind turbines, and then you've got a whole farm of them. We want to be as hands-off as possible, so they need to be really high quality, very robust systems. There's waves hitting them, there's salt water corroding parts of them. Like, there's so many things in the environment that make it a hostile place to put the largest rotating machine ever built by man out in the middle of, right? The good news, though, is it's great wind. It blows a lot more consistently and a lot more strongly than on land. So the fuel is really rich, right? It's also, as long as you're more than 25 kilometers off the coast, it's invisible to the coast. Nobody's going to be bugged by seeing anything on the horizon from their beach home. I actually love the view of wind turbines off the coast, because I just get excited thinking about all the animal life that's benefiting from that artificial reef that's been built. And there's really great studies done around fisheries and oyster beds that show the benefits to the wildlife for having these things out there. I even remember there was some study after the big Hurricane Sandy up in New York, where there was a study done of how big would a wind farm have had to have been to just slow the wind down enough to have a little less damage, for like the storm surge in New York City. And there's a lot of energy that gets taken out of the wind by these turbines. So there's a lot of ways to think about the value of offshore wind, but designing something this big and getting started on that kind of challenge is not trivial. There's a lot of risk involved.
Oh, that's fantastic. So here's one of the propellers from that, and a single rotation of these blades can power a home for 2 days. in the UK, I've read.
Yeah.
That's phenomenal. And as I understand it, there's also some very, very incredible technology that's been employed to construct these pieces itself. Could you tell us a little bit about how these turbines are made, or specifically this prop?
Yeah, the blades are pretty, it's interesting that the way that we build blades is actually, it hasn't changed a lot in terms of the construct over the last 10, 20 years. The shape of it, some of the materials have improved, but we're actually at another pivot point where we're taking it forward even more. So one of the cool innovations that we're launching now is 3D printing parts of this blade. So you can actually use different, this materials that are used here are resins and glass fiber and some carbon fiber. Which is really hard to recycle when you've got a composite of material like that. We do now have an approach, and we are recycling blades, and it's great. We're actually creating, instead of being able to use the recycled material to make more blades, we're using this composite recycled material to go into as a feedstock for cement. So you can make like a green cement because it's using recycled blades. But the innovation here is printing the blade tips and having it be a jointed blade for onshore, so that you don't have to move these really big pieces around. You can actually just move them in two pieces and then connect them in the field. And that tip is completely recyclable, and it can be made into a new tip, like it's fully recyclable, not just reusable in some other form. But yeah, these are beasts. This is a huge, huge blade.
Oh, fascinating stuff. It's very interesting to just see what's going on with 3D printing and manufacturing, and some of these industrial applications are just fascinating to myself, and I'm sure others in the audience. So thank you for sharing about that.
Sure.
I want to switch a little bit of gears now and just talk about a little bit about COVID, and specifically, what are some of the lasting impacts that you think COVID-19 will have on energy across the world?
Yeah, it's interesting. I thought going into this year, especially right around now last year, that it was going to be a really tough year in our industry. And, about 70% of all new capacity put in the world is solar or wind. So I thought, oh, our industry is going to take a big hit because we're a big part of the industry. Last year was the biggest wind year ever. We had almost double the capacity of installs in the US than the year before. It was incredibly exciting and weird, because even the International Energy Association was wondering, like, how is this working? We all thought maybe things would get delayed. Now, very luckily, we were able to, because we have a global infrastructure of plants, when we were having a COVID crisis in China, we had our plants in Asia and Europe and India, I'm sorry, in the US, Europe and India working. And then by the time the US was hit hard and our facility down in Pensacola was less staffed, our China team was back up. And this is a global supply chain, so we can send things anywhere and assemble them at the farm. So we were actually able to recover a lot better than I thought. And I think, I think the whole industry got lucky that we were in places that didn't get hit too hard, that we had to shut down factories for months at a time. But we did have to shut down. And I'm still looking back and very impressed and amazed at the commercial teams, at the installation and commissioning teams, that they could still have a banner year in a year like this. It was just a big surprise. So COVID is impact. It's a terrible thing. I would never say that there was a good thing about last year, just because it was just a terrible year in a lot of ways. But it was a surprising year as well for how resilient this space in the industry was.
Yeah, plenty of surprises for all of us, right? And along those lines, just tell me a little bit, how has COVID-19 affected your work-life balance?
That's a good question. I miss traveling. I used to travel 50 to 75% of my time around the world, visiting our customers, our factories, doing research and development work with partners. And I haven't been on a plane for work since last March. My kids love it. I have 3 kids, 2 teenagers and a middle schooler, and we got a puppy, and we're living in a beautiful place. We can walk outside. Our lives are very different than they were when my husband and I both were traveling for work in the energy space. Now we're both home, and I think it's great. I mean, I think the world won't go back to the way it was. There'll be a new normal. For us, it will be work travel, but not every time. I won't have to be everywhere. I can do this, which is great. And I've been able to get a lot more engaged with our teams on a regular basis, and not just on a monthly when I show up in India, or if I happen to be in Barcelona, we can have a discussion about it. We'll have a discussion about it in about an hour if you want, So it really has actually developed closer ties, both across work and certainly at home, that I don't want to give up. So I think we'll have a hybrid going forward once the world is accepting of travel again.
Yeah, hybridization again. I hear that. You know, just a little bit of combination. It's incredible the ways that this crisis has brought us closer, and the ways that in unexpected ways, as you said,
Mhm.
wouldn't wish it to happen again, but some
Yeah.
good things came out of it.
Yeah. And
Oh,
one thing I'll just add, Nate, is I don't think that we would, as a country in the US, and certainly I think it's stimulated the world, it's easier to talk about an economic incentive package to address climate change when it's also going to create a lot of jobs, get people back to work. I mean, this is something that two big crises coming together could actually give us the only political solution, the only economically viable solution. Maybe we wouldn't have gotten there without this. So it's, not to not to look back and try to imagine something that's not there, but it would be a much different world today in terms of talking about and managing climate impacts if we didn't have this kind of a crisis that kind of shook us up a little bit and made us look at, wow, we are in this together.
that's an excellent point, and that's a great silver lining to pull from all of this. I want to thank you so much, Danielle, for your time that you've spent with us today. This has been a terrific session. I've learned a lot. I hope our audience has as well. Thank you so much for the time, and
I
we will
appreciate it.
wish you the best.
Thank you so much. My pleasure.
All right. Goodbye, Danielle. And also, just for our folks that are tuning in, our next speech is going to be on May 18th, 2021, where we're going to talk about legacy cross-border elimination and DIMP program compliance. We'll be joining David Hecht, Darren Laux, and Jay Smith for a deep dive on precision GNSS and cloud SaaS and how it can help utilities operationalize geospatial workflows and reduce risk. So tuning off, see you all later. Thank you so much. Goodbye.